All right, welcome back. Algebra 2. Today, section 2, circles. All right, here we go. Circles, working with the distance equation. You're going to see here that for some of you guys, unfortunately, we got a bit of a connection with geometry. And if you're anything like me, I get it. Geometry was not necessarily the best level of math that I had. Um, However, I don't mind shapes. There was just these things called proofs that I was not a fan of, but we don't have proofs here, so don't worry about that. But we do have connections with geometry. Terms you're going to want to remember, we got diameter, we got radius, we got tangent, slope, you've been doing that for a long time, and perpendicular, also quite a long time with that term right there. So you're going to have parts of these problems where these terms are obviously need to be understood, but you're going to be needing to calculate maybe a diameter or a radius. You're going to have to create a line that might be tangent to the circle, which we're going to get to what that looks like. But we will need to make sure we understand this distance equation. All right, so this is something that you're going to be using in today's section. You're going to use it in the next section, maybe even the section after that. There's quite a bit of kind of versatility with this equation. All right, so there you go. That's the distance equation. Let's move into our first example right here that's already worked out. This is going to come in handy. Okay, so I'm telling you right now, when it comes to what you want to copy down from this, copy this example down, and I'd recommend this graph just because this example is what is being used for this graph right here, and it's important, but this example is going to be really helpful. It's going to be helpful just in today's notes, obviously the homework, and it's kind of like a streamlined method for when given center and radius, and they're going to ask you to write the equation of the circle real quick to jump to it. All right, so that quick, let's find the fastest method to get to the answer. Let's be honest, that's what we're all looking for here. All right, the center is a given point. The radius is a given form of distance. Now, look at even the color coordinated action they got here. This goes with x. Do the opposite of what is given. Given +5, plug in the opposite, -5. Given -2, plug in the opposite, which in this case, +2. Given radius, square it, and that's going to be that value right there. That's how they got the 64. So it really is a simple plug it in. If you are given center and radius, you can jump immediately to plugging it into the equation. You're going to have an x side with a square, don't forget the plus sign, and a y side with a square, and then you need to square the given radius. Okay, again, +5, plug in negative. -2, plug in positive. Radius 8, square it, get that 64. That's how we're going to do problems just like that. All right, so tangent. Tangent, here's your definition. And I would recommend that you understand that definition. Write that definition down into your notes that I'll be checking. So I'll be looking for that. This is a simple picture of what a tangent line to a circle looks like. It touches the circle at one given point, but it is perpendicular to a radius. All right, so this point right here, that's the radius, and you'll notice that that is perpendicular to the given point from that radius. All right, so just a simple conceptual picture idea that needs, again, to be copied down into your notes. We're going to talk about it. We're going to be using it. All right, next part here. What if you are given 2 points? One point that is really important is actually the center. So I'm not going to say that's really a point. It is, but we want to say this is the center. because then the other part of that circle that they're giving you is a point on the outside. So that means you can calculate the radius. Okay, so in other words, you're given the center, which you're going to see right here, and then you're given a point on the outside that you're going to see right there. And of course, you can calculate the distance then to get there with, yes, the distance equation. Okay, so they use the center point to represent their x1 and their y1. Then they use the point on the outside of the circle to represent their x2 and their y2. And then you plug those values in using the distance formula right here. You'll notice we have our x2s, y2s, x1s, y1s. That's how they get that. So the center represents x and y1. The point on the outside that touches the outside of the circle represents x and y2. All right, so that's simply worked out. You just go through, solve the distance equation, and then that's going to give you right there your radius. Now, once you have the radius, then you already have the center value, which was given right here. And then we do the rest of this problem just like we did this one. Here's your center, here's your radius. Simply plug it in and go. Okay? But the only deal is that you must first calculate the radius by using the distance formula. Once you have that radius, you're good. Stick to using the center, then you're going to have that radius, and then plug all your values into the equation. And of course, don't forget to square the radius right there. And do the opposite. Positive 2, it's a negative. Positive 4, it's a negative. All right? Now, this takes a little bit more time, and I'm going to leave that up there so that you can see it, you can screenshot it, you can copy down the values that you want to copy down. But the example problem that we're going to do for writing the equation of a tangent, it's a little bit more in-depth, so follow very closely with that. There's only 3 example problems, and the third one by far takes the most time. It's not going to take too terribly long, but please stick it out to the end, watch it all, copy it down. I'll check these notes later. All right, let's do it. Example problems. Here we go. First one, simple. I've walked you through this already a couple times. We're given the center. We're given the radius. Okay, so that means that we're going to be given numbers that we're going to do the opposite values of. That when we're given those opposite values, plug them into the equation. When we're given the radius, you're going to square it. All right, let's walk through exactly what we're talking about here. So the first value is an x value. And our x value is a positive 4, which means I need to plug in the opposite, a negative 4. Okay, square it, put a plus sign, start the y side. Look for the y value. It's a positive 2. That means I need to plug in the opposite, a negative 2. And don't forget to square it. You guys remember, you have to square it because that's what's going to be creating that parabola shape, that basically when you're connecting the 2 parabolas, it's making a circle. Okay, and then set it equal to not just the radius, but we want the radius squared. So that's why it's actually going to be set equal to 49. So that's us squaring the value 7 right there. Okay, so that one works out pretty easy, very straightforward. No real calculations at all. Just understand the concept and how to plug it into that equation, the circle equation. All right, second example problem. Here we go. We have a center value that we will be using in 2 different parts of this problem. And then we have a given point. This is a point on the outside of the circle. The reason why we have to use the given point is because we're going to use the distance equation to get the radius, and once we have the radius, we'll use the center, and then we'll do the problem just like we did this one right here. Okay, so let's do that. Plug in the values. There we go. Keep it in frame here. All right. Whoop. Sorry. Zoom in. Don't want to zoom in. Let's undo that. There we go. Okay. My apologies. Let's get back to it here. Push the wrong button. All right, let's do our distance formula, x2 is going to be the point x value. So let's make our big radical. And we have 9 minus a negative 3, square it, plus 10 minus 5, and square it. Okay, so let's work this out. You're going to have 9 plus a negative, which is actually going to be a positive, and that's going to give you a 12 that we're going to square. And that's going to give you a 5 that we're going to square. And this is all still under the radical. All right, so let's work this out. 144 plus 25 is 169. Square root of 169. Let's see, I believe that's going to be 13. There we go. Yes, it is. All right, so this works out to simply be 13. And this is our radius. That was the whole point of using the distance formula right there. Now that we have the radius and the center, we can jump right into the equation for the circle. Okay, so that's going to be a parentheses x. Look at the x value for the center. It's a negative 3. We're going to plug in a positive 3. Square it, plus sign. The y value is a positive 5, so we need to plug in a negative 5. Square it, set it equal, square the radius, which gets us back to the 169 value. Okay. All right, so that covers the equation for a circle when you're given the center and you're given a point on the outside. Now comes the final example problem right here. All right, so the equation of a line that is tangent. Now, when you're working with a line that is tangent, you're going to be solving for a slope, and then you're going to have to take the perpendicular slope. All right, so remember, perpendicular slope is an opposite reciprocal. So let's see how we do that. One key thing is that we're actually given the equation of the circle right off the bat. What we can do is we can pull out of that our radius and pull out of that our center point, because we've now done all of these problems where we're given a center and a radius. We need to plug it in. Now, if we pull that out, that means that our center has a value of 1, negative 2. And we have a radius that equals 5. So what I did is I used the equation of the circle and I went backwards. I pulled the center point out and I pulled the radius out because we were given that equation. And then don't forget, we will still be using this point right here. All right. So the first thing we need to do is take the slope of the center and the point. So that's going to actually give us the slope of the radius. Okay. So let's calculate that. Don't forget basic algebra equations here. How do you calculate slope? All right. Well, slope equals y2 minus y1 divided by x2 minus x1. Now, how do I know which is 1 and which is 2? Don't forget, the center is always your x and y1. The point on the outside is always your x and y2. All right? All right. Let's work this out. So the values that we're plugging in, let's see, we have a negative 5 minus a negative 2 divided by 5 minus 1. Okay, so again, that was me using the point and using the center, calculating the slope, which is the slope of the radius. All right, and that is going to give us a negative 3 over 4. So the slope of the radius, negative 3 over 4. But now what I have to do is I have to figure out what is the perpendicular slope to that. Because what I'm using now is the slope of the line that's tangent. Okay, so here's what I'm talking about. Let's go back up to that picture. All right, we just calculated the slope of the radius. That was a -3/4. Now I have to get the perpendicular line to it, which is the tangent line. And now let's go back. And what would the perpendicular line be? Let's do the opposite reciprocal. All right, perpendicular slope is 4/3. Opposite is a positive, reciprocal is flipping it. This is important to remember. I'm going to need to use that slope because now what I have to do, I'm going to need a little bit more space. I'll zoom out a little bit here. Okay, now I have to use, again, some algebra information. Let's go way back in algebra and think about what is the point slope formula, the point slope equation. And that is y minus y1 equals the slope parentheses x minus x1. All right, guys, listen, it's all good if you forgot it. I'm giving it to you now. The key thing is from this moment on, you've been presented with it. So you got to take it and remember it, write it down. We need to use it for the future. Okay. So again, what is my x1 and my y1? It's the center. What is my slope? I use that perpendicular slope, 4/3. All right. So let's plug in our values. And we have y minus, and our y1 is, let's see, actually, I got to go back. Went a little bit too far back. Our y1 is a -2. Okay, but we're actually going to be plugging in. Actually, I'm sorry, it's not the center point, it's the outside point. That was one key piece that I didn't want to make a mistake on, and I just told you the wrong thing. So don't use the center point, use the outside point. My apologies. So we're going to use the y2 value, which means it's a +5 equals a slope 4/3 x minus 5. All right, now where did I get these values? That +5, remember that's a negative sign. That is a -5. So when you plug it in, it creates a +5. That -5, there's your negative sign. There's your +5. So when you plug it in, it makes a -5. All right, now almost done. We have to distribute the 4/3 to both parts. And then we actually need to take that +5 and move it over there to make it a -5. Now comes a little bit of help from our Mr. Calculator friend here. And what you're going to do is you're going to take 4/3, multiply it by a -5. Then that answer, you're going to subtract 5. Okay. And you're going to get y equals 4/3 x. That's this arrow right here, the 4/3 multiplied by x. Then 4/3 times a -5. If you plug that in, it's going to give you a -6.6 repeating. Then you subtract 5, giving you a -11.6 repeating. But what if I want to have that decimal become a fraction? Now that's again where these graphing calculators are so helpful. Push the math button on the far left column, and number 1 has an arrow pointing to fraction. Hit that, hit enter again, and you get -35/3. And that is what we actually want. We don't want to have a fraction mixed in with a decimal. You want them both to be fractions. So this is it. This is the final solution. All right, that's what they were looking for. The equation of the line that's tangent to this circle and then the given point. So this is our actual solution right there. All right, guys, that covers it. Let's zoom out. There's example problems 2 and 3. there's example problem 1. All right, focus up, write all these notes down. If you got any questions, come to class, ask those questions. We'll see you guys in the next one.